Hey guys, today we're going to take a look at a famous physics problem called the hunter and the monkey. So let's say there's a hunter, because we want to be kind, let's say he's a scientist, with a tranquilizer gun. And there's a monkey. So the monkey is hanging from a tree, and the scientist is trying to shoot down the monkey, for scientific purposes. And when the scientist shoots, the monkey instantaneously reacts, letting go of the tree and starting to fall. And the question is, where should the scientist aim? Above, below, or at the monkey? So the answer is at the monkey. And the explanation usually given is that gravity acts the same on the monkey and the dart, so they fall the same amount. And that makes sense. Or does it? I want to look at this a different way, using a formula. So for the uninitiated, x is displacement, your change in position. So it might be something like 5 meters north or 5 feet downward. It's essentially distance with direction. V naught, V sub 0, is the initial velocity or speed, the change in displacement over time. T is time, which is, time. A is acceleration, the rate at which velocity is changing. This formula relates an object's displacement after some time t to its initial velocity and acceleration, as long as acceleration is constant, which in this case it is. Earth's gravity causes a downward acceleration of 9.80 meters per second, or meters per second squared. We usually plug in scalar values into this equation, but since x, v naught, and a are technically vectors, we can also plug in vectors into this formula, and as long as we don't do any actual calculations, it makes seeing the solution to the problem easy. First, let's establish a clear goal for the scientist. After some time t, the dart and the monkey should be in the same place. For the monkey, the displacement vector starts at the top of the tree and ends at the red x. The only component from the equation which makes it up is half at squared, since v naught for the monkey is 0. For the dart, both components add up to one vector, which must start where the scientist's gun is and end where the monkey ends up. What we already know is that for both the dart and the monkey, a and t are the same, so half at squared is the same. This means if the dart is given a velocity v naught, which leads to v naught t ending up where the monkey is, at time t, the monkey and the dart will be in the same location. And for v naught t to end at the monkey's initial location, the scientist must aim at the monkey. And there's the proof.